and engage with the latest tools and technologies within the building industry. Today, we are joined by two amazing panelists who are well-known design technologists with lots of experience from two of our favorite architecture firms, Lake Flato Architects and NBBJ Design. We are going to learn from their experience using new tools and technologies for enhancing building performance. This event will be recorded and saved on our AEC+. If you have any questions during the event, please feel free to post them in the LinkedIn or YouTube chat box, and we will do our best to answer them in the Q&A portion at the end. I'm going to briefly introduce our two wonderful panelists now, and we'll let them talk more about themselves and their work. And I have to apologize for my voice. I've had this cold for a few days, so it's not my own voice, but I'll do my best. Okay, so I'm going to start with wonderful Kristen Forward. Kristen is a design performance analyst in NBBJ and also co-leads the firm's design computation team. Kristen has an educational background in business and architecture, and her research focuses on the integration of automation into sustainable design practices. As an analyst and digital leader in NBBJ, Kristen provides thought leadership on high-performance building concepts, as well as strategic and technical leadership to project teams of the firm. Welcome, Kristen, and thank you so much for being here. So our next analyst is Daniel Stine. He's the Director of Design Technology at Lake Flato Architects in Texas. He is a Wisconsin-registered architect and an adjunct at NDSU, and he's been teaching graduate architecture students for 9 years. He has two very active blogs called Beam Chapters and Inkscape. Is an international speaker, is a co-author of forthcoming AIA Climate Action Guide for Practice, and he's the chair of Beam Standards Committee at the Illuminating Engineering Society, IES. Hi, Daniel, welcome, and thanks a lot for being here. So we are going to start the webinar. Awesome. By asking some of their work. And after the two presentations, we will have the Q&A section of the panel. And we'll start with Kristen.
Hey, thanks so much for the introduction.
Of course, feel free to share your screen.
Cool, okay, I'll do that right now. All right, good? Okay, so hi, yeah, I'm Kristen. You guys heard the introduction. I'm super excited to talk to you guys about how we're using technology to increase building performance in NBBJ. So I'll start with a bit of context on how our technology team integrates with our performance goals. And then I'll talk about some of the tools in practice, show some case studies, and then talk about some of the challenges that we have when we're implementing the tools. And then I'll talk about how we're continuing to innovate. So of course, we're part of this larger picture. We're in this area of climate breakdown, resource scarcity, all of that's coupled with an increasing population. We have to essentially double the building stock to accommodate all of this in the next 30 years. And the building industry is very responsible for a large part of the problem. And it's our responsibility as architects in this century to understand our impact and then work to reduce it. Recently, NBBJ came out with a statement that we're becoming carbon neutral and committing to net zero carbon by 2050. It's actually net carbon by 2040 now. The idea behind carbon neutral is that we're taking accountability for our own business carbon impact. So we're looking to lower emissions with the energy use in our offices, the waste we're producing, anything to do with business travel, commuting, remote working as well. And so this third-party certification will validate our claims and then prevent greenwashing. And the idea behind it is we're trying to make a real contribution by taking responsibility for our actions and kind of living our values, because we take action quite regularly through our project work, and we have been for over a decade. We have been tracking and reporting the portfolio's energy performance as part of the 2030 commitment. And at the firm-wide level, we've also joined in with many firms in signing the COP26 communique to take action that increases the likelihood of meeting the Paris Agreement's 1.5-degree carbon budget. And along with being certified carbon neutral, we were the first architecture firm to sign on to the Climate Pledge. And both of this means that we are committed to operating at net zero carbon by 2040. NBBJ's slogan is "We design for life," and the idea is that we exist to create enduring value for our clients and for society as a whole. So we're improving the planet's health, but we're understanding that people are the most fundamental aspect of this equation. So with this in mind, we have a specific group in NBBJ that's primarily focused on the performance of our buildings. But it's about more than just buildings. It's about occupants. It's about the human experience of the built environment. And our interests, therefore, look beyond energy and carbon and resource and focuses on the well-being of occupants as well. Together, our group has expertise in performance analysis, energy modeling, and we create custom tools that enable us to achieve all of this work. We train and educate NBBJ on performance design. We advise and track the certifications of our projects and the firm. And then we also offer consulting on different projects. And the way we do this is by embedding team members from the onset of projects, and then we guide project teams and clients to help optimize their buildings. So technology is intrinsic to our design work. We have a computation team that spans across our studios and works directly on projects. And the interests in this team include, but definitely aren't limited to, some newer technological trends in AEC, like web development, data mining, machine learning, as well as a lot of the relationships between, say, digital design and fabrication, relationships between our different software. And a major part of what we do is find which tasks are repetitive or of low value and then automate those. But it's not just about automating, we think of it as about augmenting design. We're there to make the design work better as well as increase efficiency. And the team is often providing training to individuals they work with, to their studios, as well as the firm at large. As well, we're constantly staying on top of emerging technology. We run pilots and we test how new tech can integrate into our design work. The two groups operate in different ways in the firm. We have a series of offices in different cities and then many different design studios that work within and across those offices. The design performance group is really goal-driven, and we have firm-wide commitments like our carbon neutral commitment or the 2030 commitment, and we work with our sustainability leaders in each studio to communicate that. These leaders will help us get involved in projects. They'll help us keep track of the goals and help us report the portfolio's performance. Then we have our design computation leaders that are embedded in project teams to gain really deep understanding of project needs. And a lot of the work as a team is born out of this deep understanding of project needs, as well as the individual interests of studio leaders themselves. The design performance group is embedded in our consulting studio, and the design computation team is part of NBBJ's larger digital team. And together, we overlap greatly. We are often working together to develop technology that focuses on innovation for performance. And a lot of the time, design computation leaders will be running performance analysis on projects, and then they'll bring ideas and issues related to the workflows that we can elevate up the chain and then turn into larger efforts. The performance group has this really amazing network within our consulting studio that we pull expertise from. We've got experts in data science, UI, UX design. We also have a lot of healthcare specialists, some of whom actually practice in medicine part-time. And the digital team has a ton of resources and specialists that tap right into. We have full stack developers that help us create custom software plugins and web tools. And this extended network is super powerful because we have a really wide range of skills within the design computation team. For example, some leads are really great at textual coding, so they work with our developers. Others are really keen on delivery and they work alongside BIM leads. And the larger digital network is especially important for how we're sharing resources and tools in the company. And this is something I want to highlight as a crucial feature to our digital culture in the company. We have an internal platform that facilitates our digital collaboration called our toolkit. And it's the sort of infrastructure backbone that helps regulate the documentation and sharing of our tools, and then contextualizes knowledge about the workflows that we use. This is just a preview of the new version of our toolkit. We have an old one that we use currently. It's on our old intranet, and it just doesn't allow you to search properly or categorize things nicely. People just aren't wanting to go there. So we worked with our UI UX designer and our full stack developer to develop this new version of our toolkit. So it has nice features for searching and filtering, and then it's a really easy process to upload a tool, and you can tag certain things so it's categorized properly. So we really wanted to make this fun and easy to use and a place that more than just the design computation specialists would want to go to. So we tie it to people as much as possible with giving people profiles, letting them like and comment on the tools, and also tying it back to our internal blogging system. So we have some really cool success stories of buildings that use computation to achieve some level of performance aspect. And I'll go through a few, and then I'll talk about how we're actually using computation and performance tools more often on project work. The Hangzhou Stadium is a great case study of using computation to optimize the building structure and then ultimately reduce the amount of material needed. This work happened back when Grasshopper was just being newly adopted into practice. Computation specialists like Nathan Miller were pioneering their use on design teams. The really cool thing about this project was the cross-disciplinary aspect of the workflow. Rhino and Grasshopper were translated into Revit, and then that was exported to AutoCAD for the engineers to run analyses, and then those results were fed back into Grasshopper. So this was, back when we didn't have Rhino inside Revit or other, really tight plugins to help us work with these workflows. So that integration between the disciplines was ultimately what enabled this ambitious structure to be optimized and ultimately realized. This one's an example of a project that wanted to use analysis to enhance employees' experience and overall productivity. The client wanted to ensure that their employees had a really high number of spontaneous interactions with each other, which is proving to increase innovation in a company. So the simulation used an in-house Grasshopper plugin to study how much potential there was for visual connections between employees in a day. The blue is on the same floor, and the red lines are between different floors. So by comparing multiple studies, ultimately the project's teams were able to arrive at a design that maximized its potential and then also balancing other design aspects. The spheres is a great example of how we can do some really complex environmental analysis to accommodate for both plants and humans. This one was studied a combination of natural and indoor lighting and controls for both people and plant life. Plants inside the spheres are from all over the world, and they have super unique requirements to thrive. And the team worked with external scientists and our internal lighting consultants to understand the calculations for all the usable light from the sun and different lighting fixtures. They made a custom tool in Grasshopper that simplified the calculation, and then it allowed for the lighting team to test different lighting schemes. So I wanted to show these projects and talk a bit about them because they're certainly worth mentioning. Some of our most innovative tools and workflows have come out of designing them, but they just represent a small fraction of what we're doing in NBBJ. They're kind of on that far end of the long tail that Daniel Davis talked about recently, meaning what we're seeing in the firm with these big projects is what the best and brightest designers and specialists have worked on. The real collective challenges in our practice lies in that fat middle, the area that's defined by more projects that have more practical design challenges and certainly more financial constraints. Our teams are integrating performance into designs every day, and often designers are performing analyses. These are just a small snippet of examples from across the board. And they're sharing this work with the rest of the company through a number of channels and definitely our toolkit. And we're finding challenges in using these tools on projects. And then they're coming up with ideas and processes to make these better. So the role that I have bridging between the computation team that's so project embedded and the overall performance group that's really goal-oriented is to track and gather this feedback and ideas, and then work to solve the problems at a more infrastructural and an institutional level in the company. So when we think about the challenges of implementing performance tools in general, they can be categorized into 3 areas. The complexity of performance tools, as they tend to have really significant learning curves and they often lack seamless integration with our commonly used software. the intricacy of interpreting analytical results. This can dissipate designers' abilities to adequately utilize data to make informed decisions. And then there's the knowledge gap between our performance design experts and non-experts. And this will slow the progression of design actions because there's not enough data to understand the design goals, understand the metrics, and especially all the tools that are available for them. So with these challenges in mind, we've developed a sort of guiding approach that has both computational and strategic methods for enabling performance design in our practice. And this is from the perspective of a team that leverages existing tools. We create custom tools, and then we also educate people on using those tools. So it starts with implementing this in work. It starts with who is implementing it. It starts with the processes that we commonly use and the projects that we're implementing performance on. The first tier of the approach looks at accessibility and usability and the adoption of performance tools. So we understand that there are really diverse sets of needs across a really large swath of stakeholders on design teams. So we've got to shift our thinking towards democratizing the capabilities beyond just specialists and approach these tools with accessibility, interface design, control as top priorities. And we also need proper organization and communication of these technologies and their surrounding research. So the toolkit's a great way for us to do that. The second tier also will focus on the integration of different specialists who input their expertise into performance evaluation, some of our strategies, and then also the development of our tools. And the inclusion of our different types of perspectives in the development will enable the data to be more mediated and also more relatable to more people. As mentioned before, we've got a really diverse network of specialists in the company, and we often are leveraging this network to explore innovation in this field. The final tier is about the translation of the really vast and growing body of research around performance into the tools and workflows in NBBJ. So we take this aspect really seriously in the development of our custom performance tools. We want to close this knowledge gap between the research and the average design team member. So we approach this by translating research directly into the tools that we make, and we approach we ensure that the expert knowledge is accessible and even integrated into the tool themselves. So I'll show some examples of the tools and workflows that follow our methodology. This is our first example. It's the Zero Guide. It's a web-based carbon estimation guide. The tool acts like a survey. Someone can fill it in at the start of a project before a geometry is even created, and they get immediate feedback on the expected emissions that their project may have. We're increasingly pivoting to web applications because they have way more intuitive user interfaces, they're platform agnostic, and they have significantly faster processing times. This tool, we really wanted to offer something accessible with a fun interface, fun and interactive, and also that displays information in a digestible manner and in graphics that design teams could just snip out of the tool and take into client meetings or project meetings. Another way that we're trying to make tools and knowledge more accessible is through making this interactive guide that I've been calling Analysis by Phase. So oftentimes designers struggle to know what questions to even ask when it comes to performance design. So this is a tool that is meant to be an easy to use guide for approaching key considerations during different design phases. It'll prompt questions to do with performance mapped across the different phases, and then it provides summarized information and links to tools and resources given a related question. So we're in development now, but this was a UI mockup that was made in Figma. We did a few different design sprints in the company and gathered a lot of feedback to validate the idea. And I'm really excited about how it's tying together all of our resources related to performance design and increasing all of that knowledge in a really easy to use web tool. We also develop tools through external relationships that we have with science experts, such as Dr. John Medina. Our work with him has led to the development of a series of tools that relate to his research, and together that forms the Applied Science Toolkit. The tools integrate neuroscience research into the tools and their documentation, and they're hosted on our internal platform as a central point of access. Along with the tools is a database for scientific research, so anyone looking at it can quickly gather evidence like short quotes or facts, and then that helps them direct conversations with teams or clients. So one of the tools is our view analysis tool. This tool is hosted on the web, but it integrates into our software that we use commonly, like Rhino and Revit. The UI UX design of this was really important for the development. It's showing pretty easy to understand graphics. There we go. So The idea behind it is that it tries to make this stuff more simple, and then it also lets you export the data in a more consumable sense. So it links to evaluations like LEED and WELL, and then it also has graphic talking points for what the data is showing. And our daylighting tool is like this too. It has custom templates that we provide when you export the information. So it'll empower designers to more competently discuss their outcomes. And this is a tool, it's part of the applied science toolkit as well. It's based in Rhino and Grasshopper. We know that most of our designers work in there. So we wanted to create something that just plugs right into their workflow. This tool specifically is a wrapper on the Climate Studio plugins and provides both a parametric option as well as something that lets you import layers from Rhino to run different analyses related to daylight. So that's a summary of some of the tools and the workflows, but I want to talk really quickly about some what we're planning to go from, where we're planning to go on from here. The innovation in NBBJ is really driven from the individuals in the company, and what we focus on is actually mainly a product of the interest of our team members. That said, we try to facilitate the innovation by providing opportunities for us to come together and brainstorm new ideas. And in the most celebratory sense, we do this in the form of hackathons. They're open to anyone who's interested or has an idea and the availability to take 3 days out of their life and quickly develop a proof of concept. And some of our coolest new tools have come from these events. A lot of them focus on performance design too. So ideas range from mobile apps that give users access to indoor environmental data in the workplace, to the innovation of our in-house training travel distance analysis plugin, to exploring visual acuity and virtual reality, and also a tool that asks how productive a space can be by measuring an equal balance between prospect and refuge areas. We also try to have a presence in the industry, like contributing to advancing innovation in external hackathons and conferences. A handful of our team members were focusing on automating analysis model extraction in last year's AEC-tech hackathon. They were developing a proof of concept for extracting geometry at any design phase and then having it ready for performance analysis. So the idea was to tighten the design performance feedback cycle. And apart from contributing to collective gatherings or events or discussions in the industry, we want to contribute in more of a form of technology. We're working on an external release of the Zero Guide tool. And the idea is to provide more useful tools that others can benefit from and hope that they help foster communication and have an impact in enabling carbon conscious design work in the industry. And I hope personally that we can do more of these, prepare more tools for external release in the future. Thanks for listening.
Thank you so much, Kristen. This was amazing. So extremely useful tools. So just a quick question, and then the Q&A section will be at the end. So these tools are all in-house, and then all the offices, all NBBJ offices have access to use them. Is that right? Just internally?
Yeah. A lot of the tools are ones that we custom make ourselves. I mean, we're definitely using tools that exist in the industry as well, but we're, as a team, kind of vetting what is the most useful. I mean, anyone is really welcome to use what they find the most useful, but as a whole, we're either using tools that exist and we're creating wrappers on them to make them more relative to our workflows, or we're creating our own custom tools that we don't see in the industry that we think are most relevant to us.
Yeah, that's amazing that you have resources and you have people to work on these tools.
It is, yeah.
That's great. That's great. Awesome. Thank you so much. So now we are going to ask Daniel a presentation, and then we will. We have a question right now, but then we'll ask the questions at the end. But we can't hear you, Daniel, now. Again. Sorry, no, we don't have your voice. I think he's joining back. Maybe in the meantime, we can I can ask you, Kristen, one question that we have here. So Navroj is asking, does the integration happen in real time, or do engineers need to tweak the Grasshopper program whenever there are changes in the geometry? So I think this is a specific question, maybe for one of the specific tools that you showed.
Yeah, I feel like it might be to do with the case study that I shared about the Hangzhou Stadium, which, that was a really long time ago. But the way that we often work, sometimes we have contractors that'll understand Grasshopper, and we can share tools with them, and it is real time. But a lot of the time, that's not the case, and we try our best to integrate engineering software into our workflows. It's a huge problem in the industry in general. So something that we're actually looking to work on ourselves to progress.
Yeah, for sure, definitely. Okay, so Dan is back. Daniel, do you want to try her voice again? See if we can hear you this time. So we have some technical difficulties today with the videos. Suggesting that Daniel, you try changing your mic to another in the setting. Do you want to try that? If you go to the setting, and you can change your mic. We can wait for a few seconds and then we can move on to more questions. Okay. Okay, so Kristen, I'm gonna ask you the next question, and then we'll wait for that in the meantime. So Paul Brachita, apologies Paul if I'm pronouncing your last name wrong. So is asking, so he's saying, Kristen, very cool work at NBBJ. His question is that is piggybacks off process in obtaining the time budget to develop these tools and secure buy-in from your internal teams? Great question. Okay.
Yeah, that's
a okay. Sorry.
Yeah, for sure. No, that's a really good question. Time is definitely an issue when it comes to trying to use these tools and develop tools. We do have people that are fully on overhead that can help us develop these tools. I mean, they're working on different projects, but the idea behind the other experts that are more practice embedded is that they find opportunities to develop them on projects as much as possible. The buy-in, it's a little different in different parts of the company. It's a global company, so some studios will have different perspectives on how useful that is. It's just a cultural thing. But typically, what we try to do to secure buy-in is to try to communicate with project teams like really early on in projects, and we say, okay, there's this opportunity to develop a tool, or we have a new tool that we want to integrate. We think that your project is a really good opportunity to do that. So, here's the people that could be involved. Here's the time that's required. A lot of the time, it's not a heavy lift if it does relate to the project itself. So that's kind of how we work to make those happen. What worked? What didn't work?
Okay, great. So yeah, he also has another question. How long did it take? What worked? What didn't? Was there an inflection point of project that really accelerated adoption? That's a great question.
Mm-hmm. Yeah, I mean, it's different for different tools. Like if I focused on a specific tool, say Rhino inside Revit, we use Rhino inside Revit all the time on project work. We have tons of specialists that use it quite often now. The adoption kind of was happening at the same time as the development of it itself. So it was still in beta testing last year. I think the new version came out last summer, and we were kind of working alongside. And then eventually, when the new version came out, it was a lot easier to integrate on projects because we could deploy it across our infrastructure more effectively instead of people having to, change the work in progress app all the time. And that one, for example, because it was so integrated into our work, it took no time to adopt as it was just really easy because we all had the skills. There are other tools that have taken longer to adopt. For example, Cove tool. It's really cool. It promises to export information from Rhino Grasshopper and also from Revit. And we tested it. We had a lot of conversations and training provided by Cove tool with different people across the firm at different project phases. And for some people, it was more seamless, especially with the Rhino Grasshopper workflow. Others that were using Revit, it was a bit more complicated because we had linked models and the tool exported in like linked models, but that was like a really common way that we were practicing. So I mean, it totally depends on the phase and how well it integrates into the practice itself. But like I said, the software integration is kind of like one of the issues. It's also the cultural aspect and the time that we have to focus on it in different areas. I don't think I can hear you, Nick Nez. Not yet. All right, cool.
Yeah. Hey, Kristen. And sorry about that. And
Hey, Kevin.
I think we're having multiple people with internet connection issues
We're good.
today.
Sorry about that. So can you hear me now?
Yeah, I can hear you.
Okay, perfect. Kevin, thanks for joining. Kevin is helping us here. Thank you. So, Kristen, I was asking, how do you keep track of this adoption process? So is it just your team who is in charge of somehow documenting what worked, what didn't work within all the offices, NBBJ offices?
Yeah, that's a really great question. We're trying as much as possible to be really methodical about that. I mean, we definitely more and more we're trying to define what will measure success on a certain project, a certain tool that we're implementing, and we will try to actually measure that quantifiably and also qualitatively as we're hosting pilots and testing tools. We're not perfect. The practice definitely struggles to measure as much as we want to, but yeah, we're often trying to track as much as possible, and the teams that do that are part of digital most of the time. I mean, I think as a leader of the computation team that cares a lot about the tools and the usage of the tools, it's my responsibility to get help from other people in the firm to make sure that we can get those avenues of tracking and measuring.
Hello, can you hear me?
Wonderful, thank you. Yeah, we can hear you. Yay.
Yay.
Awesome. Great, thank you. Daniel, do you want to share your screen with us and share with us your work?
Yes.
You work on?
The timing was incredibly imperfect. Exactly when Kristen was done, my screen just went blank, and I'm in a hotel room in the southernmost tip of Texas on South Padre Island. Beautiful place. And the little battery light on my plug-in here seemed to be working fine, but then all of a sudden everything just disappeared right at the worst possible time. So
no worries, we are happy to have you back. So it's working now. It's all good.
Yep. The exciting ups and downs of design technology.
For sure.
So I got a couple of quick intro slides. You did a great job of introducing me. Thank you. And Kristen, your presentation was awesome. It's really cool to see when firms deliberately look at some of the challenges that we face and and then also develop a firm culture around that. Great things happen, and I think you'll see some similarities in some of the information that I'm going to show. So just two additional things above and beyond what was already introduced about me. I'm originally from northern Minnesota and spent most of my life living in climate zone 7 and biking to work year round. Here's a picture of me. I bike down to 20 below, which is minus 29 degrees Celsius. And then one other thing to add to the introduction of me was, in addition to being one of the co-authors, two people from Lake Flato, two individuals from Bureau Happold, and then two other individuals, we were commissioned to write the AIA Climate Action Guide for Practice. That's coming out hopefully soon. We're actually done with it. And then I'm also on the AIA Committee on the Environment Subcommittee at the national level for climate action and climate justice. There's a group of my students that I still teach at remotely, graduate architecture students at North Dakota State University. And then quick couple of points about Lake Flato. 2019 Architect Magazine ranked us the #1 firm in the US. And then I see I have to update this slide because a week ago on Earth Day, it was announced our 14th AIA COAT Award, the COAT Top 10 Award. We have more of those than any other firm in the US, which is really quite the honor. We have 5 studios in our office. About half of our work is national and the rest regional in Texas. Here's a few examples of our AIA COAT Top 10 Awards. And then we've been AIA signatories of the 2030 commitment, the AIA 2030 commitment, since the year of its inception, and been reporting our firm's portfolio every year since then. And then, like NBBJ, we also signed this COP communique, COP 26. Part of that being deliberate about design technology and building performance in general is having an organization and a strategy and communicating it throughout the firm. So here's an example of our building performance or sustainability communication. We have a director of sustainability or building performance, Heather Holdridge, and then a coordinator that works closely with Heather and myself, Kate Sector, who then has regular meetings with each studio's sustainability champion, and then each project has a champion. So there's a very deliberate method of communication and sharing knowledge. We have a design performance action plan, or also known as a sustainability action plan, that helps guide and influence project-related decisions. And then when it comes to design technology, my title is Director of Design Technology, and it's actually a new position that's created, and partly from another cross-reference to Kristen's comment. Proving Ground had done some research and interviewed our firm and created a report, and one of the things that came out of that a few years ago was that we need a design technology director. So I came into this position having worked with the firm on a business plan and a strategy, and so as you can see, the gold area here is design technology, and it overlaps all aspects of the firm. And we work very carefully on developing workflows and training and support that basically allows the firm goals to be achieved in more efficient ways, and allows our designers to do their best work, really. And so you can see the big bubbles here of technology, our director of IT, and also our BIM manager, who worked at Autodesk for 17 years, including at Revit when it was a startup before the Autodesk acquisition, and our director of building performance. Sustainability is a big part of what I spend time on and focusing on, and also just administration, developing contractual language that would basically make sure our consultants are doing energy modeling and working collaboratively in the cloud and things like that. We use a whole host of tools. I'm just going to touch on a few of them. One of them, Kristen mentioned NBBJ using Climate Studio on the right to do annual daylight simulations for spatial daylight autonomy and annual sunlight exposure. Actually, coming soon will be a blog post on Climate Studio's website about a middle school that we're designing in New Mexico and showing this iterative process where we worked closely with the design team to develop high quality lighting in a very harsh lighting climate. In the lower left is a quality views analysis graphic. We actually worked with a developer that created an add-in for Revit that allows us to basically allows any designer to click the button in a Revit floor plan and get a view something like this. So we too are focusing on democratizing tools and maintaining a single source of truth so that we're not going down dead ends as much as possible, basically reusing geometry and data as much as possible, not always exclusively. Climate Studio, for example, they have a great Revit plugin now where you can export a Revit model directly into Rhino and do some really great things with Climate Studio. Another workflow that we use is to maintain that single source of truth and also allows design teams to do some of their own analysis is for early energy modeling, we use Autodesk Revit and Autodesk Insight, which is a cloud-based tool that uses DOE 2.2. It's ASHRAE 140 validated. It creates perimeter and core thermal zoning as prescribed in ASHRAE 90.1 Appendix G. And then on the right, you can see Autodesk has this great tool where they worked with NREL, and you can get results similar to their NREL's PV Watts website in less than 15 minutes on any project in Revit. So I always say, even if a project isn't necessarily calling for PV, we should be running this number and sharing it with the client. The AIA Code of Ethics, of course, talks about members taking time to communicate and educate environmental issues with the client. We also, again, this single source of truth, we're using Tally, which is part of Building Transparency now, and EC3 to do embodied carbon analysis and study global warming potential between different wall types, different infrastructures. We have a great report from our internal research group that is a summation of a report on embodied carbon on our website. If you go to our LakeFlato.com and the investigations page, you'll see a really interesting document there. Recently, I worked with one of our mechanical engineers in Austin, Texas, on a project that's in San Antonio, and basically we're studying the point of diminishing returns in a hot, humid climate for roof and wall thermal mass and thermal resistance values. And then we also took that same project and dropped it into 4 other climate zones. And then one of the interesting things with Autodesk Insight is it has access to the utility rates for those locations. So there's not a direct correlation here to cost versus an EUI, which is really quite interesting. And that report, actually, if you go to WGI's website, you can download this report. Again, about being deliberate and developing workflows, we have this workflow on operational energy. We have another one on embodied carbon as well, how we would do each of these tasks at different phases during a project. We also have one for daylighting analysis. I won't read through all that for you, but you can see we start early and try to do it often. That's focusing on passive strategies early on before we start getting to active strategies and then ultimately renewables that would layer on top of that to try and get to zero as much as possible. This is just a quick, interesting slide from one of my blogs on BIM chapters, showing the same building and comparing the fact that you get some really great benchmarks and reference points when you use this workflow, such as ASHRAE 90.1 2010 code. You'll get a benchmark based on the building use type. So same building, different use type. You see the ASHRAE 90.1 is different. And we also, Autodesk has a tie-in to the Architecture 2030 Zero tool through the Zero tool API. So not in a column here, unfortunately, is the Architecture 2030 EUI goal. And this is just an example of the sophistication of the workflow when you have a Revit model, and the sloped roof section on the right is actually just massing. And when you create an energy analysis model, it'll automatically convert all the planes into the correct surfaces. So that mass on the right, its bottom plane turned into a slab on grade for the energy analysis model, and the roof turned into a roof, but the overhangs turned into shade surfaces. And just for validation purposes, we're always looking at comparing tools and workflows. And I wrote a blog post on the Lake Flato website, Lake Flato's blog called The Dog Run, comparing Insight results with Climate Studio's ability to do energy modeling. And of course, Energy Plus and DOE 2.2 are very well vetted energy modeling engines. So same inputs should yield the same results. And that's what the blog post shows. They're both great tools, and they both produce accurate results. But you can also take the early energy modeling workflow that involves Insight and DOE 2.2 and take it a bit further in our workflow within Revit before the mechanical engineer gets involved, or even potentially some overlap. Here's a current project that we're working on in Montana. It's part of a ski resort. It's a multi-use facility with a gym and a retail area and a restaurant, and we're able to, within Revit, develop an accurate envelope with proper thermal resistance and thermal capacity or thermal mass, accurate internal loads, reasonably accurate HVAC using Revit's new system analysis feature. So we can define a VRF system, a direct outside air system. The gym was defined as a rooftop unit system. And then it creates an extensive report that you can view directly in Revit with an EUI and all kinds of other metrics that are really quite interesting, psychrometric charts. Here's an example just to show you those concepts, a highly accurate envelope, internal loads, and HVAC systems. So the envelope here is in the lower left where you see it says detailed. Within Revit's materials, you can actually develop an accurate wall material, one of the layers within a wall. The little example on the right, so this is actually an example from one of our passive house projects. And so this is a wall type developed in Woofy Passive House. And this is just showing that you can develop the same exact level of detail in Revit. And of course, if you were to change the thickness of the material, the total thermal resistance and thermal mass, which thermal mass is also really important and often overlooked in some of the competing tools. And so the little green arrows show the same 100, R value of a 100. And this is actually just more of an extreme, like when I was talking about the point of diminishing returns, the R100 is pretty high. And then in the upper right, when we're working early in the process, and as I mentioned, a massing element, when it turns into the energy analytical model, the surfaces, their properties, thermal resistance and thermal capacity, are defined by dialog box selections, not Revit materials. And we have we've worked out a method where we basically hack in the program files for a Revit an XML file, and we have our own standard wall types that we can use. There's 50, 60 standard wall types in there, and the nomenclature actually matches the minimum requirements in ASHRAE 90.1 Appendix G, and there's even a straw bale wall type in the list, which is pretty amazing. But we can add our own wall types, and again, they're super accurate. This layering of a wall assembly that you see in the lower left in Woofy and Revit is exactly how it's expected to be plugged into Energy Plus. And so that was the envelope definition. And the internal loads definition, this is all just out of the box Revit stuff. On the far left, you can define the internal loads at the building level. But then if you use Revit spaces, you can define the internal loads at the space level. So each space can have different heating, cooling set points, occupancy, lighting and power schedules, light density values, as you can see here. So there's a schedule on the far right. And then there's some things baked in. You got to kind of look in Revit's help define this, but schools, for example, have the US holidays and a slightly different summer schedule baked in. I have a lot of this on my blog. Also, when you talk about wall assemblies, there's an example on my blog of how to account for thermal bypass if you're trying to make your own stud layer with insulation. But interestingly enough, the R13 plus 3.8 built-in Revit wall type is already derated to an appropriate overall R value that accounts for thermal bypass, which you wouldn't type in R16.8 in any energy modeling program when it says the minimum is R13 plus R3.8. So here's one other look at developing the internal loads. So when you select a space, in addition to having a space type, this one over here on the right, the space type is set to exercise area. And then per that previous dialog, it has all its own internal loads. But then there's some overrides that you can do if needed for this one space. So here we plugged in the area per person. So same thing a lot of us architects do on Revit rooms and creating all kinds of parameters to track this. For Revit spaces, this idea of area per person is already baked in. And then when you create the energy analysis model, that then contains the calculated load. So the occupant load of 40,775 BTUs per hour. And then we can create a space schedule in Revit that lists the occupant load and then compare that with the spreadsheet that the architect's been working on separately to see that the load, which is obviously an important thing in calculating internal loads, the latent people heat gains, for example. All right, and then here's an example of within Revit, when you're using the systems analysis tool, locally on your local computer's CPU and hard drive, you can do an Energy Plus run initiated through OpenStudio. So you can do anything in OpenStudio. It's like unto Grasshopper to Rhino, Dynamo to Revit, OpenStudio to Energy Plus. You can create these measures and these scripts basically that can swap out the entire HVAC system for a radiant floor system or a geothermal system. And on the right, the system browser shows all the spaces, and you can see there's a VRS system, and there's the fitness studio. So the architect's room name and number come through to the spaces when you use the space renaming tool. And then finally, you get this well, actually, this isn't quite the report yet. This is showing on Autodesk's website the assumptions that are made, like the coefficient of performance for heating and cooling for the VRF system. Architects, for example, don't need to know all that stuff. Some of it's pretty common. But then if you really want to, using OpenStudio and some custom shared parameters, you could make a cooling coefficient of performance and have that pull through and actually override these values. Here's the report. So in Revit, on the right in the project browser, this is just incredible. There's this reports node that shows up once you've run an Energy Plus run within Revit, and then the different reports over time. Here's an analysis of the VRF with the direct outside air system. You can see on the right, it's sort of cropped, and I had to block out a little bit of the project name, but it used Energy Plus version 9.1. The EUI is 31.56 for that entire building that you saw. And this also includes the rooftop unit. And in the properties here, the report style can actually be switched from detailed. I forget what the other option is called, but there's this whole interactive little pie charts that animate themselves, and you can click to expand and hover over the little pie charts to see the lighting, the percentage of energy that's coming from lighting, coming from pumps, coming from all the different major systems. And then, as I mentioned, I just wanted to share this. I think this is going to be amazing for the industry, and it's forthcoming. It's not available yet, but this climate action guide for practice that I had the privilege of working on. We were again commissioned by the AIA, Lake Flato, Bureau Happel, and two other individuals to develop this 20,000 word document. It actually parallels the framework for design excellence, where that is all about projects, right? Buildings, doing good buildings. This is a little bit more reflecting inward on the practice and making a practice more sustainable. And a little graphic that you can see there was sort of the results of a yet another sort of parallel effort that I did, testing power consumption in a VDI scenario, comparing the power of an architect or engineer's powerful desktop with a powerful graphics card, which uses something like 250, 260 watts pretty much all the time. And then if you use these newer sophisticated NVIDIA graphics cards on the Dell host, but still robust enough to open our largest projects in Enscape and have a good frame buffer, the power consumption can be dropped to like 71. And that's just raw power consumption. You think about at my house, I have a 26 SEER HVAC system, but then I also had a zoning board installed. So it's even more exponentially more efficient, because during the day, more than 3/4 of my house, both my wife and I work from home, and we're actually remodeling our office in San Antonio, Lake Flato is. So, most of our house isn't being cooled or heated, mostly cooled. We live in Texas. So that ability to schedule computers and have them just turn themselves off at night when half of the hardware isn't needed is pretty amazing.
Yeah, for sure. Daniel, sorry to interrupt you. It's actually 2 p.m. I mean 12 p.m. PTM. We are over with time. I don't know if you lost Kristen or not. But since we started late and we had those technical difficulties, maybe if it's okay with you and Kristen, we can go for another 5 minutes, if it's okay with you.
Yeah,
we'll
it's
take
totally
some of
fine.
the questions.
Yep, I'm happy to.
Okay, perfect. Thank
Sorry
you so
again
much.
for my technical difficulties and throwing us off schedule here a little bit.
No problem, no problem. Daniel, sorry I interrupted you. Do you want to maybe continue? Were you done with your presentation?
Yeah, I can be done. Yep, there's
okay.
1 or 2 more slides, but it's fine.
Great, wonderful. And then, I'm going to ask you the same question that we asked Kristen. So what is your adoption process for these new tools and software. So do people usually approach you, or do you go after the tools that you need? And then how does it work? Do you test several tools, like for the insights that you mentioned and some other tools like Climate? So do you test them, and then are you the one who decides what you're gonna adopt in your process? How does it look like?
Yeah, that's a great question, and I'll start sort of backwards. It'd be really the worst thing, I think, if I were the only one making the decision. So I definitely enjoy my job. I get to try things, and I'm always exploring and looking for new opportunities. And of course, you can imagine the number of emails, unsolicited emails and things that come in about all the new amazing things in the world. But part of the process of democratizing a tool and a workflow is to try to build knowledge base around it and not just have every tool and let everything. But we're not adverse to different tools, but there's definitely the process oftentimes is to identify a need, to try and validate and test a tool to make sure it actually works properly and is consistent. I mean, we all do, proof of concept and cutting edge things, and we even present on them often, but oftentimes we're not always, it'd be about, oh yeah, we've only done this on one project, or we've never really done this on a real project. But like our Cloud XR that we're doing, for example, I presented at NVIDIA's GTC conference on it, and we are using it on one real project right now, and we hope to, pushing our VR partners to try and support it. And but yeah, it's like a little bit of everything. Obviously, we try to find workflows again that are consistent, have valid results, that we think staff will use and embrace. We have subject matter experts that we gather around to have meetings and try and come up with a group decision on if we want to embrace something fully or partially and try it on a sample project, a pilot project. It's honestly just a little bit of everything, and some things just sort of organically come out on top. Like Enscape is the only visualization tool we use now, except for Photoshop and a pencil. 80% of our staff, again, democratizing a workflow, use Enscape, which is pretty amazing.
That's great. Yeah, that's a great tool. Awesome. Thank you so much. So Kristen, someone actually asked you, let me see, Shibei Huang. She asked how many people are in NBBJ's computation team full time?
Yeah, I saw that Pergy answered that in the chat. We have about 20 design computation leads, but they're not full time. So the question, if it's about, if it's fully overhead, then we don't really have any design computation leaders that are fully overhead in the firm. Everyone is embedded in projects. So even myself, I'm only like 30% embedded in that team, and everyone else ranges from maybe 5% of their time to 10 to 15 and 30. It just totally depends on the individual and if the studio is kind of willing to put up that time and they see the value of it.
Awesome. Thank you so much. I'm so sorry that we can't address all the questions. We are 5 minutes past the time. Dear audience, please feel free to follow Kristen, Dan, the blog post that Dan is actively posting, and reach out to them and ask them the questions. I'm sure they both are so wonderful that they will answer them separately. I wish we had more time, but I don't want to keep you more than that. And thank you so much, Kevin, for organizing this great event. And we're gonna the recording of this event will be saved on our channel, and so feel free to watch that later. Thanks a lot, and have a great rest of your day.
Thank you so much for organizing this. Thanks, Dan, for sharing. That was really, really interesting to hear.
Great, thanks. Bye.
Bye.
Everyone.
Everyone.